Good day, everybody, and welcome to the RTCA EUROCAE session on future connectivity. We have a little session planned for you today from the RTCA and EUROCAE Special Committee and Working Group. So those are SC-216 and WG-72. We have a joint committee that works together on developing standards for cybersecurity considerations in aeronautical systems and aerospace as a whole. So we've got three panelists here today. We'll do a quick introduction and then dive into a few topics for you. My name is Patrick Morrissey, and I'm one of the co-chairs for the RTCA SC-216 working group. I also work for Collins Aerospace and have been working with them for the last 30 years doing a number of things in the area of cybersecurity. Cyril?
Yes, Cyril Rosé. I'm senior expert cybersecurity in aviation at the European Union Aviation Safety Agency, so a bit the equivalent of the FAA. And I'm chairing working group 72 since 2019. Yes, and Siobhan?
Hi, I'm Siobhan Nikes. I'm the other co-chair for SC-216. I've been active in the committee since 2016. I am a tech fellow for Boeing Commercial Airplane, and I've been working for Boeing for almost 20 years now, mostly in cybersecurity roles. Thank you.
Okay, so I'd like to start us out with introducing a little bit of what our joint committees work on and what we've developed and what our current scope of work is. So we have a set of standards that we've developed to help guide the industry. Walking through those real quickly. So I know numbers and remembering these numbers can be problematic, but just a summary. So DO 391 is a peer document with ED 201. That's the Aeronautical Information System Security Framework Guidance. Then we have DO 326, which is a peer document with ED 202, currently at revision A. That's the Airworthiness Security Process Specification. And then DO 356A and ED 203A are the Airworthiness Security Methods Considerations. So the first of those, that pairing of documents, is the process and how you execute cybersecurity considerations in design and airborne system design. And then the second is the methods and considerations, the first being the what, the second being the how. So then the next document specification that we've developed is DO 355, paired with ED 204. That's the Information Security Guidance for Continued Airworthiness. That's for more of the guidance for operators for maintenance of the aircraft and aircraft systems that relate to security. Then we have DO 392, paired with ED 206, the Information Security Event Management Guidance. This is how do you process and deal with security incidents and events when they occur, kind of giving insight into how to evaluate them, how to consider them in your overall life cycle process. Then there's DO 393, which is paired with ED 205A, and that's the security certification of ATM ANS ground systems. So we have a couple updates that we're currently working on within our current tour. That's terms of reference. So we're working on updates to DO 326 ED 202. We're going to update that to revision B and include better guidance on security change impact analysis. So CIA is a normal part of the aircraft certification process, but what are the considerations that need to be given for that in support of cybersecurity? So there's been a request for some refined guidance, some more detail about how to do that for industries. So we're pulling that information together for the next revision. Then we're also updating DO 392, ED 206. We're going to be updating that to revision A to address some performance requirements for event reporting. Again, feedback we've gotten from the community on more refinements, more detail that they'd like within that standard. And then we're working on two new standards. So those are the DO/ED. Right now, we're just calling it ISMS. It's not numbered yet. It will by the time it's released. And this is to help Again, provide some standard methodology guidance for how to implement an information security management system, similar to SMS, the safety management system that our industry is fairly familiar with. This will be an information security management system that aviation organizations can implement, and it will eventually seek to provide a methodology to support certification, support compliance with the Part IS standard. And then last, our final document we're working on is what we call the DSEC standard at the moment. Again, it does not have a number issued yet, but it is going to be a standard on aviation data security. So considerations for how do you secure the data, aviation relevant data supply chain, what we call our data supply chain, how data moves through the system that eventually goes to the aircraft. What are the impacts that data could have on the operational environment, and how should that be protected? Again, giving some guidance to those that manage that data, handle that data, store that data, and help them understand what they should be doing to protect it and understand the importance of that data. So right now, then, I'm going to turn it over to Cyril, and he's going to give a little insight into why these standards are important in light of data connectivity in the future of aviation.
Thank you, Patrick. So as you mentioned, EUROCAE Working Group 72 together with RTCA Special Committee 216, they have developed a quite comprehensive suite of information security standards that are tailored for aviation. So in the context of the future connectivity, the importance of a standard is about, I would say, level playing field, so that you have a common means to implement recommendation, regulations, and specifications. And in this particular case, there is a white paper that was published by Airbus, Boeing, VFA, and EASA. And in this white paper, you know that there are some recommendations for information security, in particular to address confidentiality, integrity, and availability, using 3 levels of assurance that are commensurate with the risk on safety, security, and performances for the communication of the data. So also you have the fact that we expect to have an hyper-connected ATM technology, and we assume that it will become acceptable to use public non-safety commercial communication systems as a component of aircraft safety communication. And the demonstration that safety, security, and performance requirements are met will have probably to be supported by the implementation of end-to-end system that will be developed with the expected design assurance level and security assurance level, and that the security mechanism that are implemented on the transport of data, for example, VPN, authentication mechanism, encryption mechanism, will provide the assurance that the security properties are commensurate also with the risk. So you mentioned the existing standard. So we have 3 standards for airborne systems that provide some assurance with respect to the impact on safety. We have also one for ground system, also with a different assurance level, and we have standards also for organization. You mentioned the one for the event management, and the future one that develop an ASMS. This ASMS, we expect, if it implements the MCs and the acceptable means of compliance of the EASA regulation on organizations, also you will have 3 levels of rigor for implementation of security mechanisms. So you have this, by level, depending on the impact, level of rigor that you have in different standards. And then you have the one for data, the future DSEC, and this standard, we expect that it will propose an approach also based on assurance that the data is secure from production to disposition in a manner that is commensurate also with the risk, so that we don't have to implement strong security measures on data that are in fact very little safety impact. And so it has to be commensurate. And the objective is really to find a coherent security protection between organization, ground system, airborne system, all along what we call a functional chain. So let's take the example of the data communication from an air traffic control to an aircraft via the ground infrastructure, the space infrastructure, the aircraft systems. So all this will have, so you have a chain of systems and data. And the strength of the chain will be the strength of all the systems, the data mechanism together. It has to be homogeneous all along the functional chain and to the appropriate level. And the standard that we have developed, they all already have this ready. So far for aircraft, for ground system, and ED201, DO 391 which is about the framework, also provides a tool to align all these different assurance levels so that it's possible to maintain coherence along the functional chain. So that in short how we expect the standard developed by Special Committee 216 and WG-72 to contribute to the security of the future connectivity in aviation. But this, of course, is the short term, the next few years. And the digital environment evolves a lot, and so I think we leave now the room to Sylvain, so that can maybe answer the question that where do we see the technology in 5 and 10 years?
Thank you, Cyril. Okay, so where do I see the technology in 5 to 10 years? And I have a long answer for this one. Obviously, we're going to see increased connectivity and more cloud-connected systems, and there are so many different use cases for this. One of my favorite use cases where I see a lot of advancements is weather data. So how much can the pilot gather from the aircraft ahead of them? They can change flight plans to avoid storms and have safer routes, fuel burn efficiencies, which benefit the operators. It leads to cost savings, but it also helps the environment. I see implementation of emerging technologies. So things that we are imagining now, working now, are coming into fruition. Internet Protocol Suite, IPS, is going to be a big one. That's the next gen protocols for air-to-ground safe communications. Wireless Avionics Intercommunication System, or WAKE. Wireless communication between those different avionics boxes at a specified frequency. And we're working standardization of that now, and including cybersecurity. So I definitely need to talk about UAS and autonomous systems. So I see all of these diverse use cases in UAS and autonomy actually coming into fruition. So this drives the need for different standards and regulations. And I'll say this time and time again, it's not a one-size-fits-all problem, solution to the problem, I'll say. When you look at the differences between a drone that drops off your packages to a military drone to cargo and air taxis, and this isn't limited to new classes of aircraft. We're seeing auto land and auto taxi features now, so there's going to be a lot of enhancements to those features in the next 5 to 10 years. So in the same vein, AI machine learning, let's talk about that. That was a hot topic at the Aviation Cybersecurity Summit last month in Dublin. And so AI machine learning, of course, is an enabler for UAS as we're looking at increased levels of autonomy. So I see in the next 5 to 10 years, a lot of advancements in that space. Specific to cybersecurity, I see a lot of aggregating of the data to identify cyber threats, being able to find and fix vulnerabilities sooner. But of course, we need to address cybersecurity of the AI machine learning code itself. And we need to look at that intersection between AI machine learning, UAS, and cybersecurity. We can't do this standardization and the development of the technologies in silos. And then speaking of which, RTCA is actually planning a workshop in AI machine learning and emerging technologies end of November. So I'm excited to participate in those discussions and see more details come out on that. Another thing that we'll see more of in 5 to 10 years is the gathering, aggregating, analyzing of more and more data. How are we going to use all of this data? One use case for this is predictive maintenance. How can we use this data both on and off the aircraft? How can we automate the process? Really increasing that potential to see a part failure sooner, or even a cyber attack that we previously would have missed. Another thing I see in the next 5 to 10 years is widespread, and I'll say normalization of model-based systems engineering tools and techniques. We can use MBE to streamline design changes and the associated risk analysis associated with that. Also streamlining certification, utilizing digital twin for testing, and then standardizing digital artifacts to prove airworthiness. That's not going to be too far off. So with that long list I gave you, the main takeaway is that as technology evolves, we must continue to consider safety and cybersecurity aspects early to ensure its success. And we're already doing that now through our standardization. So I'd like to thank the audience today for listening to this talk, and my colleagues, Patrick and Cyril, and I will turn it back over to them if they have any final words.
Thanks, Siobhan. No, it's a great insight on future technologies and where we're going. I think it also highlights through many of those examples how the importance of the process specification, because the initial standard that we wrote, DO-326, ED-202, are really about security in your process, whatever you're developing, whatever your product, whatever the function is that you're building, thinking about what are the threats to that in the overall aircraft system, and then thinking about how is that mitigated. Because by coming back to that central process, right, whether it's AI or some element of connectivity or UAS, whatever the additional element that's being built out for the system, the process will help define what are the threats and lead you to where those mitigations need to be applied. So that's super great. Thanks for that overview, Siobhan. Cyril, anything else to add?
No, thank you for letting us presenting our work at Special Committee 216 and Work Group 72. I hope you appreciated and that you are more aware now of the complete set of standards that have been developed for airworthiness security.
Awesome. All right. Well, thank you, everybody. Thanks for attending. Have a good rest of your day.